Hello guys, welcome to Gradeup. Myself Abhishek Shukla. Today we are going to have a very important topic for GATE point of view. It is digital circuits. Okay, digital logic or digital circuits. I have seen the previous paper analysis which I did. It is asked about 8 marks. It is always very often 8 to 10 marks it is asked. So I would like to have you a conversation that from where are the topics especially asked. Okay, the major chunk was asked from sequential circuits. Combinational was asked, but approximately the question they were a bit focused on minimization of minimization using k maps and all those things. Okay, but in today's topic we are going to have a very special focus on sequential, because in sequential a variety of questions including various concepts from other domains are also asked. So today I prepared the question, and my team in fact prepared the question, and we prepared the question involving the certain concepts of different streams also, so that we may bring you to a very important flow, that how to attend the questions and how to not get panic in the examination if the questions are unseen. Okay, so a very important approach which we will be opting here will be, after seeing the question, what you have to do, where you have to pursue, and in which domain you have to see yourself. Okay, moving. So in analog, I think that the RPI model the RPI model will be asked in GATE, so you have to be very much comfortable in that. See, friends, those who have studied common base model, I would just like to study one model or two model. I studied only one model, so you also know that what is the common base model. If common emitter model is known to you, you can attempt for common base model. Okay, Bharat Singh, hi. Is this for CS also? Yes, you can. You can. UT CBSC. Sorry, Pranav, I don't see T CBSC. Yes, Shubham, it is for CS also, because digital logic is also asked there. Means it is in their subject also. Okay. So friends, I would like to say that at this point of time, 25 will be the approximately cutoff. अगर आप demoralize हैं, एग्जाम नहीं दिया, जीरो पे तो है ही हैं. Give mock test, have a very clear cut idea in which domain you are weak. Practice that domain. Okay, practice that domain, be comfortable in that. And I would just like to say that if you do hard work, then you will easily get what you want. Are you aiming for PSU? Are you aiming for IITs? Are you aiming for ISC? Or you are aiming for anything? Okay, you will get. See, you have to reach till this. Okay, you have to reach till this. The only thing which you have to do is have confidence in you and do hard work and just revise. Have formula sheet, revise and revise. Okay. So I think that people are joining. Thanks, Dex. Okay. So you have to be confident in yourself. Okay. You will certainly, agar koi ek kar raha hai, then you also can achieve. Okay. So you have to do practice and you have to do hard work. So let's begin with the today's session. And on the screen there is one question. Okay. So try to attempt it. The question is in D2. Okay, it is Q2. I think that it is Q2. It is Q0. And it is Q1. And it is Q0 bar. Okay. It is Q0 bar. So, and in the second, it is in the second D2. Okay. It is this side it is D2, this side it is D1, this side is D0. Okay. The transcripts are a bit small, so I would just like to justify that. The upper one is Q2 bar, and here Q0, and it is Q1 Q0 bar. Okay, friends, this type of question, you are very much confident that it is a straightforward question. Okay, it is straightforward question. So I would just like to say that this type of question, pursue with present state, whatever the excitation is given to that, and also the next state. Okay, the next state. So the present state of Q2, Q1, Q0. Excitation will be D2, D1, D0. Okay, D2, D1, D0. Q2 plus, Q1 plus, Q0 plus after applying the clock pulses. Okay, after the clock pulses are applied, the next state will be this. Okay, so start from the initial. Okay, let it be 0, 0, 0. It is reset. Q2. What about Q2? Q2. What about D2? D2 is Q2 Q0, Q2 Q0 plus. It is OR gate applied there. Q1 Q0 bar, Q1 Q0 bar. D1 is also Q2 bar, Q2 bar Q0, Q2 bar Q0. Okay, and Q1 Q0 bar plus Q1 Q0 bar, and here it will be XOR. Okay, XOR gate is placed. So Q1 XNOR with Q2, Q1 XNOR with Q2. So these are the states, and you have to. Option B. Okay, binary to access 3 converter. Sorry, my friend. Yes, sir, I'll make it fast. Okay, I'll make it fast. My speed depends upon your response. Okay, my speed depends upon your response. The more quick you respond, I'll just speed up. Okay, so it will be 0, 0, 1, and in D, we know that in D flip-flop, the value of D, okay, Q plus is equal to D. Whatever the value will be stored in D, it will come to Q plus. Next state, it is called transparent latch. Okay, so it is 0, 0, 1. It is 0, 0, 1. Again, after solving these expressions, you will be getting 0, 1, 1. So it will be copied in D. 0, 1, 1. So again, it will go as 0, 1, 0, 0, 1, 0. 0, 1, 0, the next state will come as 1, 1, 0. Again, the next state 1, 1, 0. The next state will be 1, 1, 1. Okay, my friends, please solve these. Okay, 1, 1, 1. From 1, 1, 1, we are going to have 1, 0, 1. 1, 0, 1. The next state 1, 0, 1. We are going to have 1, 0, 0. 1, 0, 0 is the next state. Okay, so the next state which will come is 1, 0, 0, 0, 0, 0, 0, 0, 0. So we are getting these states. Okay, these states. Okay, so after getting excitation, solve it, means put the values and get this table. This is the table which you are going to get. Okay, so I would just like to have a very brief discussion that this is the table, and what about binary? In binary, okay, my friends, see, here it is binary. Here it is binary. And what is this? It is gray code. 0, the gray will be 0. Binary 1, the gray will be gray 1. Okay. So if you analyze this table up to 7, if you analyze, okay, then here you are going to get this. Here you are going to this. Okay. You are going to get this. After 3, there comes the binary 2. After binary 2, you will get this, 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 this. So friends, okay. Thank you, Rama. So friends, here you are getting this. Okay. And I can tell you that it is gray counter. Gray counter. Okay. After you have been to this, you have been to this, you have gray counter. Okay, you have gray counter. For those who are predicting is as binary to gray access 3, so sorry, it is not access 3. Here it should be 1 0 0. Okay, you can see it from the table itself. Okay, binary to gray code converter. No, it is not binary to gray code converter. It is actually gray counter. Okay, it is actually gray counter. Okay, the way of explanation is not very tough because actually मैंने इसको बता दिया, टेबल बना दी, मैं देख रहा हूं कि कोई सीक्वेंस आंसर से मैच कर रहा है. वेदर आर यू गेटिंग एनी सीक्वेंस और एनी ऑप्शंस फ्रॉम द आंसर? द ऑप्शंस गिवन, इट इज नो. सो चेक इट वन बाय वन. इट इज नॉट बाइनरी काउंटर बिकॉज यहां पे 2 आना चाहिए, 0 1 0. सो इफ यू फॉलो इट then you are getting a gray counter because the binary gray it is this, the binary to gray it is this. So you will be comfortable with that. Okay, thank you. Let's begin with the second question. Okay, the second question, try yourself. These type of questions, the questions of sequential, often occur and you are supposed to put something extra. Means you have to be very much attentive. अगर ऑप्शन में ग्रे काउंटर दिया हुआ है तो you must think that why it is given, because in gate you have to analyze each and every means aspect of the question which it is asking. If it was just simple counter, okay, binary or binary to see, check the options and the truth table which you are drawing, check it from there only. Okay, so this flip flop which is given, it is D2 and this flip flop is D1. Okay, D2 D1 and it is T naught flip flop. Okay, T naught flip flop. So try to solve it. What will be the mod? The correct answer is answer D. It is gray counter. Okay, so friends, in this type of questions, like it is saying that the T naught is fed with clock. Okay, D2 and D1 are fed with the clock, that is the output of T naught. Okay, so it is a sequential circuit. As it is D2, it is D1, negative edge trigger. Okay, clock is fed. Okay, so here you are having this. Okay, this is the second stage which you are going to analyze. Why not binary to gray? Actually, it is not binary to gray converter. You go to that option, the truth table which we have drawn. Okay, and you just analyze whether the given, the present state and the next state, if it is binary and here it is equivalent gray, then it will be binary to gray converter. But here it is not binary and here it is not gray. The options are not matching, means it is not the equivalent of the gray code is not the equivalent of the given binary. So you have to leave it. That option is left out. Okay, so here friends, what will be the initial stage? Q2, Q1. Next stage will be Q2, Q1 plus. Okay, and the clock is applied. What is the clock? The clock is output of Q naught. Okay, that is the output Q naught. Okay, so let the initial states be 0 0. Q2 plus will be Q1 bar. Okay, Q1 bar means it is 1 and it is 0. Okay, and here 1 0. Q2 is 1. Okay, Q2 is 1 and here it is 0. So the next stage which you are going to get is 1 and 1. Okay, 1 1. The next stage will come out to be 0 1. Okay, see my friends, here it is given the output was 0 and it is 0. So here it will be 1. It will come again on the next clock. So it will be as 1, and if here it is 1, so again it will come as 1 and here it will come to 0. Okay, so you have to go through that phase. Okay, so the next clock it will be 1 0. Okay, and here it is 0 1 and the next state which it will be looping to 0 0. How? again it is 0, it is 1, so here it will be 0, this 0 will be fed to this place, and here this is 0 and here this is 0. The next clock when it will come, it will store as 0 and it will store as 0, it will be 1. Okay, so again it will go to this. Okay, so what is the number of states? 1, 2, 3, 4. 4 states. It is having 4 states. Okay, 4 states यहाँ पर हैं next stage पे. Okay, so I would just like to have a brief discussion of T flip-flop. That T flip-flop, T0, here it is Q0, here it is Q0 bar. Okay, it is fed with the clock pulse. Here it is 1. T0 पे 1 है, it is always toggle. So the frequency, suppose the clock frequency is F. So what will be the frequency of this? The frequency will be F by 2. How? Suppose it is a clock pulse. Okay, suppose it is a clock pulse. Positive trigger, take it as positive trigger. Okay, so if it is 1, clock goes to 1, and again when the positive pulse will come, it will change. Again when it is the positive pulse, it will change. Okay, so the output frequency will be, okay, I hope that you are getting it. Okay, the output frequency will be F by 2. ये F by 2 है और यहाँ पर नंबर ऑफ स्टेज 4 हैं, आगे कैस्केडेड है F by 4. सो कैस्केड करने पे F by 8 विल बी द रिजल्टेंट. F by 2 यहाँ पे हो गया फर्स्ट स्टेज पे. ओके, वी आर नॉट गेटिंग क्लॉक. या एक्चुअली द क्लॉक, सी द क्वेश्चन वंस. क्वेश्चन में दिया हुआ है कि द क्लॉक of the next stage, that is D flip-flop, it is fed to, the clock of D is fed by the output of Q. The clock to D is fed by output of Q. यहाँ पर F by 2 हो गया फर्स्ट स्टेज पे और D flip-flop वाला पूरा यहाँ पे लगा हुआ था. And I solved and I told you that the number of stages are 4. 4 stages. जितने नंबर ऑफ स्टेजेस होंगे उतना ही आउटपुट का जो फ्रीक्वेंसी है वो डिवाइड होगा. नंबर ऑफ स्टेजेस इज इक्वल टू F by 4. F by 2 cascaded with F by 4, it will be F by 8. Okay, it will be F by 8. So mod of that will be 8. Okay, mod of that will be 8. Explain with pulses. Okay, I'll explain the pulses. That's very good. Okay, I'll explain the pulses. See, first pulse, second pulse, third pulse. I hope that it is looking like pulse only. Okay. Okay, suppose these are the pulses which are given. Okay, so take the first value of T. See my friends, you have to be very much alert about clock कहाँ से fed हो रही है. Okay, and what are you supposed to do in the expressions? It is the clock which is fed. Are you getting it? It is the clock which is fed. T0 will toggle on the positive edges. T0 will toggle on the positive edges. Okay. T0 will toggle on the positive edges. Positive edge toggled. Okay. Again positive edge toggled. Positive edge toggled. So now this T flip-flop, the output is Q. The output is Q, and this Q is fed, and this Q is fed for the next clock, and the number of stages are 4. So my friends, जब यहाँ पर आएगा, when it is negative pulse, then it will remain as on. Okay, since the number of stages are 4, so it will be down. It is negative. Okay, so I guess that it is down for 4. Okay, So the total mod which you will count is the frequency will be f by 8. Okay, so mod will be 8. Go from this logic. Okay, go from this logic. So my friends, the very next question, is it helpful for CS? Actually, you need to go through your syllabus. Okay, my friend, this is a very good question. Okay, this is a very good question. Personally speaking, you are going to get very good concept from this question. Okay, so try this question. Question number 3. Friends, Sachin Verma, very good. You commented a very means relevant answer. The answer was correct. So my friends, third question which is on your screen, attempt fast. Okay, in GATE you have to be precise in calculations. You have to be very good in speed. Okay, like fast and furious, but without any plan B. You have to crack GATE, that is plan A, and you should stick to it. Okay. In counters, okay, in counters, registers, you have to be very much familiar. Okay, while writing this, okay, this register which you are getting, it is 0, 1, 1, 1. Okay, and here you are getting an XOR gate from this. Okay, and this from the first register and the last register, and it is feedback, okay, with the clock pulse, and it is feedback with the clock pulse. Okay, got it. It is not very tough question, Rohit, ऐसे देख के छोड़ना नहीं question. Enjoy the question, go with the flow. Okay, you will enjoy this question. So let the clock pulse is 0 initially, the clock pulse is 0. Okay, and here it is Q3, Q2, Q1, Q0. Okay, actually I want that you should go through all these questions right from the beginning. Okay, digital plus analog, yes, Rohit, it is digital plus analog. Okay, but analog bhi utna nahi hai that you must fear of. Okay, in the first clock, XOR these two bits, it is 1, 0, 1, 1. Go to second, the second clock is fed, again 0, 1, 0, 1. Third clock is fed. Go to those many steps. What is the question asking? The question asking, find the average power dissipated in 1K, that is the load. Okay, till the register values, till the register okay, state reaches 1, 0, 1, 1, 1 again. So count the number of clock pulses where the register values reaches to 0, 1, 1, 1 again. You have to be very much cautious about XORing these two bits. You have to XOR these two bits and reproduce the same in the next. Okay, you have to again XOR and just go through those many steps. Okay, so what I guess and I calculated that in about 15 clock cycles, I will be getting the answer as 0, 1, 1. So this type of circuits are also called pseudo random generators, pseudo random code generators. Okay, what is pseudo random code generator? In CDMA spread spectrum hota hai. In CDMA all the frequency means the same frequency is allotted to all, but these frequencies are discriminated by pseudo noise codes. Okay, this pseudo code is generated by this circuit. Okay, it is called pseudo random generator. 7, no Rohit, no 7 तो option ही नहीं दिया हमने. And yes, assume one thing. In this type of questions you have to be a bit like the power dissipated in this means it will be take it as 0.2, so whole current will pass through this. Okay, so when the clock pulse is 15, it will repeat itself. Okay, the register values repeat itself. Okay, so now comes the concept of BJT. what is the concept of BJT? Here it is high. So the VCE, the value of VCE, what is this phase? VCE will be, it will be acting as on. Okay. And here it is 1K resistor. Here it is 0.5K and here 5 volt. Okay. अगर यहाँ पर 1 आया, it will be acting as on state and the value of the resistance through VCE, जो VCE का resistance है, okay, that will be nearly equals to 0 suppose. Okay, and then calculate the value. The current will be passing through this. Okay, current तब pass करेगी जब यहाँ पर 0 होगा. It will act as off and the current I will travel through this path. I hope you are getting. Hello Yash. So you have to follow that path. Okay. If it is 1, it will act as on. If it is on, the current will follow this path. The current will follow this path. Okay. So friends, go through this. अब अगर मैं एक चीज बताऊं कि जो 15 क्लॉक्स थे, जो 15 क्लॉक्स आपने काउंट किए, उसमें हमको केवल और केवल जो लास्ट बिट थी ना Q0, जो लास्ट बिट थी Q0, ओके, केवल उसकी वैल्यू से मतलब होगा इसके ऑफ और ऑन में. और जो उसकी वैल्यू थी, ओके, सी ऑप्शन, नो, नॉट सी ऑप्शन, राज, नो, इट इज नॉट द सी ऑप्शन. ओके, so there was 7 zeros that occurred. Okay, there was 7 zeros that occurred. और जब ये 0 रहेगा तब ये ऑफ रहेगा और करंट इसमें पास करेगा, तभी पावर डिसिपेट करेगा. ओके, हेलो, तभी ये पावर पास करेगा. जब ये ऑन रहेगा, जब ये 1 रहेगा, ये ऑन रहेगा, तो यहां पर कोई करंट नहीं जाएगी. ओके, सो getting that concept, there was 7 times the output of Q0, the output Q0 was 0. Okay, so P average will be T off time. T off time कितने टाइम तक वो ऑफ था, तभी करंट जा रही थी, अपॉन T on प्लस T off, ओके, इनटू P पीक, जो पीक पावर थी, जो पीक पावर थी. T on was 7, T off was total 15, okay, into what was P peak? P peak was V upon R plus RC, okay, whole square into R, I square R. Okay, so the answer which you will be getting is 1.03 milliwatt approximately. Okay, the answer which you will be getting is, no Rohit, please have a calculation once more. It is 5, it is 1K, it is 0.5K and it is again 1K. Go through all this and you will be getting the answer as 1.03 milliwatts. Okay, so the nearest option is option A, which is correct. Okay, जितने टाइम तक ये ऑफ रहेगा उतने टाइम पर इट इज ऑफ, ये ऑफ है तभी करंट यहां फ्लो करेगी. दैट इज व्हाई वी हैव टेकन टी ऑफ. अदरवाइज सारे फॉर्मूलाज में वेयर वी डिसाइड द एवरेज पावर, टी ऑन बाई टी ऑन प्लस टी ऑफ वी टेक. ओके, सो यू हैव टू बी वेरी मच अटेंटिव इन द कॉन्सेप्ट एप्लीकेशन ऑल्सो. ओके, I did not get the concept of 7 times 0. How? Rohit Yadav, yes. देखो यार, actually I'm sorry. देखो means when you are getting Q0 clock, so it is Q3, Q2, Q1, Q0. Drawing the whole state diagram. Actually the whole state diagram says It was the first clock, and it was 1 1. It was 0 1 0 1. It was 1 0 1 0. The next stages which will come. Okay, so the next stage will be 1 1 0 1, 0 1 1 0, 0 0 1 1, 1 0 0 1, 0 1 0 0, 0 0 1. Okay, so 0 0 1 0, 0 0 0 1. 1 2 3 4 5 6 7 8 9 10. Okay, so it will be 1 0 0 0. आपका एक भी आंसर ऐसा नहीं होगा जो कि अनआंसर्ड जाए. ओके, आई विल क्लैरिफाई ऑल योर डाउट्स. ओके, you don't need to carry any doubt from this point. So this was the thing. How many times it was off? वो ट्रांजिस्टर कितनी बार ऑफ था? One time जब Q2 0 था, because Q2 is applied directly to the base. 2 times, 3 times, 4 times, 5 times, 6 times, 7 times. 7 times it was off. जब ये 7 बार ऑफ था तभी तो करंट उसके थ्रू जा रहा था RL के. Okay, now the very next question, solve it. My friends, you have to be very much attentive कि जो भी रजिस्टर्स, जो भी शिफ्ट रजिस्टर्स या जो भी बना के दिए जा रहे हैं, what is the mod of it, you must be very much comfortable in the mod, number of states. जितने नंबर ऑफ स्टेट्स होंगे वही mod होता है. ओके, so try this question. 4-bit ring counter, 4-bit ring counter, n-bit ring counter, n-bit ring counter, number of stages is n. N-bit Johnson counter, n-bit Johnson counter, number of stages is 2n. Number of stages is 2n. Okay, n-bit synchronous up counter, n-bit synchronous up counter, the number of stages will be 2 raised to the power n. This thing you have to keep in mind. Okay, take this concept, this thing you have to take in mind. Okay, so starting from this place, we know that if the number of states are m, one counter is this, and it is cascaded with n, it is cascaded with somewhat l. See, these are states of the counter. So the next, with the net which we are going to get is m n l. Okay, take this concept. 256 is the correct answer. Sachin Verma, after getting this concept, try once more. Okay, you will get that answer. So what will be the f? F will be the input which is fed. F will be the output which is appearing upon what is 4-bit ring counter. Stages will be n. 4-bit Johnson also, so it will be 2 into 4. 3-bit synchronous counter, so it will be 2 raised to the power 3. And the answer which you will be getting is 256. Correct answer. Yes, Rito, the answer is correct. So in the next question, see, given the arrangement of digital logic circuit, the initial value of the components are 0. The reset and the clock pulses are applied to the 3-bit Johnson counter. This Johnson counter सारे clock pulses और reset यहीं पे applied हैं. Okay, and all the value of the counters are reset initially. So what will be the value that will be the output of the priority encoder at the 9th clock pulse? Surup Reddy, please go through the concepts. Please go through the concept here. Here again there is a up counter. Up counters are placed. Okay, ring counter क्या होता है? Ring counter is just like D flip flop. Okay, ring counters are just like D flip flop, and the value are this. It is fed like this. Okay, it is D and Q. Okay, it is fed. So while analyzing the state diagram, you will be getting as F is equal to F by N. N is the number of stages. N is also the number of bits जिसका counter बनाना है, जितने bits का counter बनाना है. Okay, and in synchronous, and in if you are getting it as Johnson counter, so Johnson counter is also known as twisted counter or walking counter. So feedback will be applied like this. It will be Q0. ओके, D2 Q2, ओके, ये ऐसे अप्लाइड रहेगा। ओके, सिंक्रोनस काउंटर में एंड के साथ में, ओके, एंड के साथ में वी फीड द सक्सेसिव स्टेजेस। ओके, सो लेट्स गो थ्रू दिस कॉन्सेप्ट। ओके, जॉनसन काउंटर, इस क्वेश्चन को सॉल्व करने के लिए सबसे पहले राइट डाउन द ट्रुथ टेबल ऑफ जॉनसन काउंटर। जॉनसन काउंटर की ट्रुथ टेबल के बाद आप ये देखिए कि जॉनसन काउंटर की डिफरेंट जो बिट्स हैं, 3 बिट्स, वो किसको किसको फीड हो रही हैं। दैट विल बी एक्टिंग एज अ क्लॉक। टेक इट ऑल एज लेवल ट्रिगर्ड, दीज ऑल आर लेवल ट्रिगर्ड। ओके माय फ्रेंड्स, इट इज लेवल ट्रिगर्ड। ओके, mind in the diagram, this is level triggered. So Johnson counter, what will be the truth table? Truth table will be J2 J1 J0 0 0 0, clock is 0, clock pulse is applied, it is a walking counter, so one will act like it is walking. Okay, so the truth table which you will be getting is this. Okay, second clock pulse, third clock pulse, fourth clock pulse, fifth clock pulse, sixth clock pulse. So the number of stages is 6, n is equal to 6. So a 3-bit Johnson counter will have 2n stages, that will be 6. Take this concept. Okay, so ये जो J2 है, this J2 is fed as a clock, this J2 is fed as a clock to up counter. मगर यहां पर बोला है 9th clock pulse, so it will be 7th clock pulse. What you will be getting? You will be getting answer as 1 0 0, 8th clock pulse 1 1 0, and what will be the 9th clock pulse? 1 1 and 1. Okay, the 9th clock pulse will be 1 1 and 1. J2 is fed as a clock to the up counter. So the number of levels that will be counted, 1 2 3 4 5 6. So जो ऊपर वाला अप काउंटर है उसने कितने पल्सेस काउंट की? 6 पल्सेस. Okay, mind my friends, I'm writing like this. Up counter, okay, up counter has counted 6 clock pulses up to this. Okay, now J1 1 2 3 4 5. So the down counter, there is 2-bit down counter. How you realize that it is 2-bit down counter? Okay, down counter, okay, that down counter has counted 5 pulses. The number of ones which are occurring will be level triggered. That's why I said that it is level. Okay, the number of levels that it counted was 5. 1 1 1 1. Okay, the number of levels is counted was 5. So again a ring counter. Okay, 1 2 3 4. 4 levels ring counter counted. Ring counter counted 4 levels और 4 levels. Are you getting this? अब काउंटर के पास इसका आउटपुट फेड था 1 2 3. Okay, you are getting this much. Okay, Sachin Verma 4. No, Sachin, 4 is not the answer. Try to check it again. Okay, you are very close to the answer, but 4 is not the correct answer. Okay, so अब काउंटर की इनिशियल स्टेट्स कितनी होती हैं? 0 0 0. स्टार्ट किया 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0. जब क्लॉक अप्लाई हुई, फर्स्ट पल्स, सेकेंड पल्स, थर्ड पल्स, फोर्थ पल्स, फिफ्थ पल्स, सिक्स्थ पल्स, so the output of the up counter will be 1 1 0. Now down counter is of 2 bits. See, the output is given 2 bits. देखो यहाँ पे जो आउटपुट है, यहाँ पे 3 बिट्स हैं, तो guess it is 3. It is 2 bits, so the down counter is of 2 bits. Okay, 0 0 when nothing was there, reset. Okay, clock pulse applied 1 1 0 0 1 0 0. Okay, 5 तक काउंट किया, पहली पल्स, दूसरी पल्स, तीसरी, चौथी, एंड इट वाज फिफ्थ पल्स. फिफ्थ पल्स ने क्या काउंट किया, और द आउटपुट विच वाज प्रेजेंटेड एज 1 1. रिंग काउंटर, four bits were counted, okay, and the output of the ring counter was 3 bits. So 1 0 0, 0 1 0, 0 0 1, and again the fourth is this. Mind my friends one thing, that it is from this it is I0, okay, and here it is I7. सबसे ऊपर I0 है, नीचे I7 है, okay. Take that thing in consideration because it is very small given, that's why I am doing it, okay. So it was like this. Now what the output which you are getting, 1 0 0, it was I7, I6, I5, I4, I3, I2, I1, I0, okay. और जो आउटपुट प्रायोरिटी इनकोडर का है, that will be Q2, Q1, Q0. Okay friends, that is Q2, Q1 and Q0. So the value of bits are 0 0 1, 1 1, and it is as 1 1 0, so it will be 1 1 0. Okay, so tell me, priority encoder, if I5 is 1, तो यहां कुछ भी रहे, it will decode it as 5. It will decode it as 5. Likewise, यहाँ पर कुछ भी वैल्यू रहे, if I5 is 1, so it will be 1. In priority encoder, if the value of I3 is 1, तो यहाँ पर कुछ भी रहे, means अगर आपकी MSB 1 है, जो भी है highest MSB is 1, so यहाँ पर कोई भी वैल्यू रहे, it won't affect. If I3 is 1 suppose, so the value will be 3, that will be the output, okay. So the value of the output will be 5, 5, 5 is binary, okay, decimal value will be 5, okay, decimal value will be 5. Sachin, again, you are looping around 5 only, but you are not getting 5. So my friends, see the very next set of question, that is good question. It is of transmission gates, okay. Transmission gate, CMOS logic is actually asked, okay. CMOS logic is asked again and again, okay. The output is the negation, okay, or the inverted logic. So in transmission gates, try to get this concept. The upper one is TG1, transmission gate 1, the downwards is TG2, transmission gate 2. What will be the implemented? I0 should be 1. Pramod, please go through it again, and you tell me whether how the I0 will be 1. This the value of the transmission gate logic that is being asked, okay. Yeah, Pramod, that will be 1 1 0, so it will be I0, I1, and it will be I2. But actually it will not affect the answer again. It will not affect the answer again, okay, because you will be getting it, okay. It will not affect the answer, okay, because the MSB is 1. MSB will be considered from the downwards only. MSB will be downward, okay. So the next question, which is of transmission gates, C answer, okay. No, it is wrong, See my friends, in this transmission gate logic which is given to you, if A is high or A is given as 1, let us take a concept. It is NMOS. When 1 is applied, it is conducting, okay, it is conducting. And suppose in PMOS, when 0 is applied, then it is conducting, okay. Consider that case, and See, the upper one is Tg1. It is NMOS, given below is PMOS, and it will be acting as a perfect. It will act as a perfect, means pass the logic when A is equal to 1. A is equal to 1. The downwards logic. Okay. So the output Y, that will be B. Okay. That will be actually B. When A is 1, you will be getting the logic. Tg1 will be on, Y is equal to B. And when A is equal to 0, the output will be B bar. So if you try to tabulate it, then the output will be A X NOR B. Try to tabulate it and get 6B. No, 6 will be A option. Sign. Yes, you have solved correctly. 6 will be A option. So friends, agar A will be high, then NMOS will pass the logic. लेकिन अगर NMOS, if it is NMOS और यहाँ पर 0 है, it will act as a high impedance. Okay. See, don't go to that. Just be attentive here only. Are you getting it? Okay. So next set of questions will be posted on our app. Okay. And I hope that you are going through a very good preparation at this point of time. Okay. And my friends, be focused. Only 20 days are there. Keep away yourself from all the social media, including WhatsApp. अब ये WhatsApp का time नहीं है. Okay. And try to give mock test. Okay. Try to give mock test. And there are 20 days. Give at least 5 mocks. Be focused, be prepared. Okay. You will surely gain in this examination. Because अगर कोई एक भी स्कोर कर पा रहा है इतना, अगर कोई एक भी 85 स्कोर कर रहा है, so why not you? You can. Okay. If you wish, you can, you will, certainly. Okay. That will be the spirit. That with that spirit you have to prance like lion and beat the examination. Okay. Crack the examination. Okay. Crack the examination. But be very much focused on your exam. And yes, while solving the paper, always think of one thing, that this exam is very important and it will make you to land to your destiny. And you have to work for these days and try to set up a routine, get up early in the morning, because gate paper will be in the morning. Okay. To try to set up a routine right now. Otherwise in the last day, pata laga gate ka paper and you are feeling sleepy. Okay. So focus and revise the formulas and go through all the things which are which you have learned, formula sheets, revise them and be comfortable. For any queries, please post your queries in the Gradeup app section of queries. We are going to help you out over there. Okay. With the very next set of questions, we will be again live. Okay. So friends, thank you for joining Gradeup and all the best for your examinations. Thank you.